Have you ever wondered what really happens inside your computer when you press the power button? Or how websites load in seconds? Or how one computer can run multiple systems at once? In this lesson, we'll break everything down step by step, no prior knowledge needed. So, what exactly is a computer system? At a basic level, it's made up of two main parts: hardware and software. A simple way to think about it is this: hardware is like the body of the computer, while software is like the brain that tells the body what to do. Now, let's start with hardware, which simply means the physical parts you can actually touch. Inside every computer, there's something called the CPU, or processor. This is basically the brain of the computer. It handles calculations and makes decisions. Then there's RAM. You can think of RAM as short-term memory. It temporarily stores the data your computer is currently working with. We also have storage, like SSDs or hard drives. This is your long-term memory, where your files, apps, and documents are saved, even when the computer is turned off. All these components are connected by the motherboard, which allows them to communicate with each other. And of course, none of this works without power, so there's the power supply unit, or PSU, which provides electricity to the entire system. Now let's talk about software. Hardware on its own can't really do anything. It needs instructions, and that's where software comes in. The most important type of software is the operating system, like Windows or Linux. This is what manages everything: your files, applications, memory, and even connected devices. On top of that, you have applications, things like web browsers, games, or editing software, which are what you actually use to get things done. That's the basic idea of a computer system. Hardware does the work, and software tells it how to do it. So, what actually happens when you press the power button on your computer? A lot more than you might think. The moment you press that button, the computer starts a whole chain of events behind the scenes. First, the power supply turns on and sends electricity to all the different components inside the system. As soon as power reaches the CPU, it wakes up and starts running a small built-in program called BIOS or UEFI. This program is stored on the motherboard and is the first thing your computer runs. Next, the computer does a quick system check. This is called POST, which stands for Power on Self-Test. During this step, the computer checks if important components like the RAM, CPU, and keyboard are working properly. If something isn't right, you might hear a beep or see an error message. Once everything checks out, the computer looks for a place to start up from, usually your SSD or hard drive. It then loads something called a bootloader. The bootloader's job is pretty simple: it loads your operating system. After that, your operating system, like Windows or Linux, is loaded into memory, and the CPU starts running it. At this point, the system begins to feel alive. Then, all the necessary drivers and background services start up. This includes things like your keyboard, mouse, graphics, and other essential functions. Finally, you'll see the login screen. And at that point, your computer is fully ready for you to use. If you want to keep it simple, just remember this flow: power, BIOS, system check, bootloader, operating system, and then login. Let's talk about the different types of computers, because not all computers are the same. The ones you're probably most familiar with are desktops and laptops. These are general-purpose computers we use every day, for browsing, working, watching videos, and more. Then we have servers. Servers are more powerful computers that are usually always on. Their job is to handle requests from many users at the same time. For example, when you open a website, you're actually connecting to a server somewhere in the world. There are also embedded systems. These are small computers built into other devices, like ATMs, cars, or even smart TVs. Unlike regular computers, they're designed to do one specific task, and do it really well. Now, let's look at how computers communicate with each other. When you visit a website, your computer acts as a client. It sends a request, basically saying, "Hey, can I get this web page?" That request goes to a server, which processes it and sends back the data, things like HTML, images, and videos. For this to work, a few things are involved. First, IP addresses, which help your computer find the server. and then HTTP or HTTPS, which are the rules used for communication. HTTPS is the secure version, it encrypts the data so it can't be easily intercepted. Now, let's talk about something called virtualization. Virtualization allows one physical computer to behave like multiple computers. This is made possible using something called a hypervisor. There are two main types. Type 1 runs directly on the hardware, while Type 2 runs on top of an existing operating system. Each virtual machine acts like a separate computer, with its own operating system and resources. This is really useful for testing, improving security, and reducing costs. Finally, let's talk about cloud computing. Cloud computing simply means using computers over the internet instead of relying on your own machine. So instead of doing all the work locally, you're using powerful servers somewhere else. There are three main types of cloud services. IaaS, where you rent virtual machines. PaaS, where you build applications without worrying about the servers. And SaaS, where you simply use software through your browser. A good example is online email. Your data isn't stored on your device, it's processed in the cloud. The big advantages of cloud computing are pretty straightforward. You can access it from anywhere, it can easily scale as your needs grow, and you don't need to spend money on expensive hardware. That's the big picture, different types of computers, how they communicate, and how modern systems use virtualization in the cloud. So, to wrap things up, you've learned how a computer actually starts up, how hardware and software work together, how systems communicate with each other, and how modern technologies like virtualization and cloud computing fit into the bigger picture. That's a solid foundation, and honestly, this is a big first step into the world of IT and cybersecurity.